Good afternoon once again, everybody. Hopefully, this session will be a good one as well and give you some knowledge about our new products, or rather, our new application. Okay, so the topic for today is the enhancing machine maintenance safety with key in pocket solution. The main focus is the key in pocket solution for today. And let's have a look at the agenda today. Okay, sorry, it's one. Okay, so the agenda today is we're going to introduce some identification and access management. That's our IAM system and its role in the industrial security. Then we're going to talk about our award-winning key in pocket solution, how it works, what kind of application that it can be used, have a quick visual video to show how it works in the real life, and then we will have the Q&A at the end. And as Grace mentioned, you can use our Q&A function of the Microsoft Teams, or you can put some question in the chat. Okay. All right, let's get started. So first topic, we're gonna talk a little bit about the safety requirement first, so you will know why we actually certify our system, what is the need. Okay, so from years ago, we used what we call machinery directive. So let me put the pointer here. Hope you can see. Okay, so machinery directive is basically a safety requirement for the machine, and of course, basically is used for European Union. Now in 20 of January 2027, that machinery directive will be replaced by machinery regulation. So with the machinery directive, we look at the safety part of the machine. Okay, so let's see some example here. So basically, when you talk about machinery directive, you try to design the machine, and you can eliminate the risk. You can eliminate the hazard. You can put safeguarding device to protect the person from the hazardous movement of the machine. Now, and that you can do that with the harmonized standard that you have seen in the past. We talked about it in some of our previous webinar. But the thing that we want to focus is security part of the new machinery regulation. Okay, so previously this was not included in the machinery directive, and it is now included in the machinery regulation. So what is it? Now we have a look at some example. Okay, so if the yellow picture right here is the machinery safety part of the machinery's regulation. The right picture is the security part of the machinery regulation. We put the color blue just so to differentiate the machinery safety and the security safety. Okay, so what changed? So previously we make the machine safe for us to access. Okay, now we actually have a requirement that to prevent unauthorized access by the operator by another person to access the machine. So let's say if you have a safety parameter in your machine, at the moment, if anybody have the username password, you probably be able to change something, modify something. It doesn't matter if you are qualified or not, right? But the machinery regulation put the security requirement as part of the requirement for the machine safety. So now you have to be able to identify the person, see if he has the right permission to access the machine, basically to prevent some corruption of the machine and lead to some kind of failure or hazard. Okay. Now, for the security part, we have a few involvement with the different regulation, different directive, different standard. Now, first thing, we look at the machinery regulation. So you can find out a few more details about the machinery regulation. We have a webinar session for that. And if you would like to know a little bit more about machinery regulation, you can contact us, and we have the link to share. Okay. For the security part under machinery regulation, so basically there's a requirement to protect against corruption, and the security that focus on the functional safety function. So as I said earlier, there could be a safety parameter, there could be some kind of safety function that could be easily bypassed or defeated in the past because there's no requirement to prevent such attempt, right? So now the machinery regulation have this requirement. So all the machine that want to be CE marked have to fulfill them, and security is part of that. Okay. Then with another involvement, the standard ISO 13849-1. This one we talk about safety control system, right? And there's the few things, but one of the update in this 2023 version is that they update the additional requirement for the skilled person. So the employee, previously the skill that they need, right, is sufficient training, experience, basically to perceive the risk. So you know what's the risk of the machine and how to avoid it. Now, additional requirement is related to the access to the machine. So the skilled person, does he or she have the right access? Right qualification, and then you give the right permission for that person. Okay. What else involved with security? So there are also the network and information security, or it's called NIST. And this time around is version 2, so we call it NIST 2. This is the directive in European Union. Once again, all this apply basically in the European country, right? Maybe not directly to us at the moment, but it is good to know ahead of time because, as I mentioned, some of this will be required in the future if your organization required to follow European Union requirements. Then this will be a good knowledge to know. So network and information security NIST is a directive. Basically, it addresses how essential important entities that have to have a measure to managing the cyber security risk. Okay, this entity is depend on the category that they fulfill. So basically, not going to go into detail, but essential entity is like a big company. It could be government related, or it could be just a private company that if something wrong, if there's a cyber security risk and something go wrong, then it affects the large group of people. Okay. For example, what is it? Banking system, financial system, power plant, right? Drinking water system, which is affect the wide range of people. Now, the important entity also have the same responsibility, but they are a little bit smaller scope, smaller impact, I guess, compared to the essential entity. Okay, but this is the smaller smaller organization, and they will have some impact, but not as much as essential entity. Okay, so just the requirement that they have to manage their cyber security risk in this NIST 2. Then the last thing is the Cyber Resilience Act. This is the regulation. Okay, so basically, if you are a manufacturer of the products with digital elements, let's say HMI, for example, safety PLC, safety controller, right, or programmable safety relays, then you have to follow this act. Okay, and you have to make sure that your products, okay, have a way to prevent the security risk. Okay, one of the things that example, I guess, that you can think of, that I can think of is, let's say you have hardware, okay, safety controller, and also then somebody can hack your safety controller, right? Then the manufacturer have to provide the fix, so the firmware upgrade for that particular product, and this is mandatory in the near future. Okay, so basically for Cyber Resilience Act, it may not affect end user, right? But mainly is the manufacturer of the products with digital elements. So these four are basically involved with the security. Okay, now this is just a quick summarize. So in January 2027, then all the machinery in European Union, if you want to sell them and use them in European Union, then you need to fulfill the machinery regulation requirements, which also include the security aspect. Okay. So if it does not meet, you cannot sell. You cannot sell the machine, or you cannot use actually the machine in the European country. Okay. We have a little bit link there. We can share that later if you want to look into the machinery regulation. Okay. Now, so we talk about security, right? So what Pulse can do for you, can support you, can help you. So we have four aspects regarding the security. So first, we are a global company, as you may know, and then we have experts around the world, basically expert in the machinery regulation, the standards, and specification regarding the security. Then Pulse also provide training for security. We provide consultant service for industrial security, and we have the products that can be used regarding the industrial security. Okay. So for the training, we have what we call CISA, Certified Expert for Security in Automation. And basically, you will learn about the requirement for cybersecurity. The main standard that we're going to tackle is the IEC 62443. And what you're going to get from this course is basically you learn how to correct application and implementation of the standard, this particular standard regarding to the cyber security. And also you be able to assess and optimize your existing plan with regard to cyber security. Okay. Now, we don't have it offered here locally yet. We do have the global training for this. But if anybody interested, please feel free to contact us. Okay. Now, what else we have? So for the service, we provide industrial security consultant service. Okay. So basically, we do analysis of your system. Okay. What damage can be done, how likely it is. Right. If you go back to machinery safety, you may be thinking of the risk assessment, the PLR, if you're familiar with it. So you define a different factor, see what is your risk level, for example. Then you do the assessment. Yeah, how would the attack really be done? Okay, and we provide some concept, so security concept. Okay, what can be what protective measure can be done to improve your system, and then we verify your system. Okay, so that's the service for this security. Now we want to look at the key focus for today, which is our products. We have many years past security breach, this green device right here, and that is used as a firewall, for example, to prevent unauthorized access from the outside of your factory or maybe remotely to your machine. So this provides the network capability, but also make sure that only the authorized person can access to this device. Okay, to the machine that connect to this device. Then we have what we call PIT OE. This just the Ethernet and USB port, okay, which we can incorporate with our system in order to make sure that, okay, if you have the right permission, then you can plug in your Ethernet cable and access the PLC for example. If you want to reprogram, if you want to monitor something, and you need this access, then this device can be used to have another protected level, instead of having Ethernet connect directly to your PLC, right? You connect to this device, and this device will work with other access management control that we have, which we will be talking about soon, to allow or not allow the person to access your PLC. Okay. Now, the main products of the day, PID reader. So this is the identification device that you check the access uh, uh, of the person. So in here, we have the PID reader, look like this, and then we have the PID key. So that's the transponder where you plug it in and it check whether or not you have the right access. Okay, so these are the three products that we can use for the security application. Now, let's have a look more in detail about our key in pocket solution. So first, I would like to provide some definition for our identification and access management, or the IAM system that we have. So there's three things that you need. Okay, so first you have to have identification. So who is that person? Who is the operator, right? So you have to know that. Then you have to check the qualification and skill of that person. Okay, so let's say this person A is the operator, right? So what is the level of training? Is he a beginner, or is he expert? Is he the supervisor, right? Then after that, we define the access or the permission level for that person, right? So if he's just operator, right, he may be able to access certain part of the machine, but maybe not able to configure parameter of the machine, for example. If you are a supervisor, you have a little bit more access, you have more permission, you could edit some kind of parameter on your machine. Or if you are maintenance personnel, then you have access to perform teaching on your robot, for example. So these three in combination is part of our identification and access management, or IAM. Okay. Now, previously, without this system, of course, if you have or if you found the username and password to the PLC, then anybody can access that PLC. And it could lead, if you have experience, of course, no problem. If you are new to the system, you may make some mistakes and cause a malfunction to your machine. So our IAM system want to prevent such thing to happen. Okay. Now, what are the basic components for this system? So basically, we have physical identity, or our transponder PID key. Okay. Then we have identity evaluation device, our PID reader, to identify the access level authentication. Okay. So how does it work? So basically, you have your transponder, the person have transponder, then you need authentication for the system. Then you plug it in to your PID reader, and the PID reader will do the authentication to see if this transponder have the right access. If he doesn't have the right permission, then he is disallowed to access the part of the machine, for example. But if he has the right access, then he is authorized to access the HMI PLC, for example, okay, or maybe access certain part of your machine. So that is the general workflow for our IAM system. Okay, now what does our device do? So the PID reader itself contains a bunch of information and can provide those information right here, which can be used for the different controllers. Okay. So we have the 24 volt digital output, safety digital standard digital output that can be used to trigger that. So if this key is authorized to do something, then it can send out the output. With the information from the key, the PID reader can read the ID, the permission data, etc. Okay, so this information here, can be used to connect with the safety controllers, safety PLC, and later on be used for the other thing. For example, to allow the machine to unlock the guard, to allow the machine to perform, allow robot to do the teaching, for example. Okay. Now let's see how it works. So if we look at the initial situation, okay, what would you normally see? So you have a dangerous area. Let's say we talk about the robot cell this time. And a lot of time, robot cell is protected by fence, right? Metal fence. Then if the operator need to enter the area, what would happen? So you need to shut down the machine, right? And then go inside. Okay, so basically you perform a lockout tagout, right? And then you go inside and access the area. And uh, according to the regulation or procedure, you are not allowed to switch on the system again until everybody come out, right? But how can you identify that? How can you know if everybody is out, right? Is there an easier way? So this is where our key in pocket comes in. So our key in pocket allow the person to allow the system to keep track of who is inside and who is outside by using this PID reader and the controller. So basically, when you first start off, you are an operator. You bring your transponder key, you insert to your PID reader, right? Then you access, let's say, sign in, what we call sign in, to access the area. Okay. It can be more than one person, up to 20, to access the area. And during this period, if you have not signed out yet, the machine cannot be restarted. Okay, so if you think about it, it's similar to the lockout tagout system, and that is mechanical lockout tagout, right? But it's a bit more flexible because sometimes you want to shut down the whole machine, or you want part of the machine to have the power to do teaching, for example, right? So you can do that with different permissions. Okay, once you finish all your tasks there, right? You go inside the work, you perform your tasks. Once you finish all your tasks, then you can just sign out, right? So everybody have to sign out first. The list has to be empty. Then you can restart your machine and continue running. Okay, so this will help to make sure of course, if you didn't sign in, then that's another issue. But if everybody do according to the procedure, sign in when you go in, right, and sign out when you come out, then this will help to make sure that the machine will not start if somebody inside. Okay, that is the key in pocket solution. Now, our solution is also certified by TÜV South. Okay, because we using it for safety application, it has to be certified. So basically, we have the identification of the person and the protection against accidental startup of the machine, while as long as the user remains signed in. Okay. With this certification, with this certified solution, we can achieve up to PLD category 3, according to the EN ISO 13849-1. And up to SEAL 2, according to this EN 62061 and IEC 61508 standard. Okay, and of course we do have a technical report from the TÜV, and this is actually the world first e-lotto system that had been certified. So previously, of course, you may use the padlock, right? Lockbox, the lotto system mechanical part, And this is the world first electronic lotto system. Okay. Now, if you want to implement this key in pocket solution, what do you need to have, right? Basically, first thing you need reader, right? Because you want to be able to identify the access. Okay. Then you have the safety controller. Okay. It could be our safety small controller, PNOS multi, MB1, or our safety PLC, PSS 4000 right here. Okay. And once again, it's up to maximum of 20% in the list, right? So at one point in time, maximum of 20% can access can be put in the sign-in list. Then what else you need? So you need LED buttons. Okay, when you want to, request the access, you want to sign in, you need those buttons with the LED because we're gonna use that for the status, which I will talk about it a little bit later. Okay. Then there are some optional devices that you can use as well. So what are they? So you can use our card locking device, PCM lock with the door handle modules. Basically, you want to make sure that nobody get access inside, right? Until until the machine is safe, and then you can unlock it with the right permission. So this device can be used in your system, in your machine. If you want to have an easier diagnostic functionality, then you can use our PMI, which is the HMI of pills, which will show who is signed in, who has signed out, right? And those kind of detail that can be appear on the screen. Then you can also use some kind of third-party tower lamp if you would like to use the tower lamp, right, to provide some indication of your machine. It might be easier that way you see on top of your machine, right, what the current status. Is everybody signed out already or still sign in? So we have different options for that. But basically, you would need these three to implement your key in pocket solution. Now, so how does it work? So right here, we have some example for sign in, sign out, and check. Okay, for this slide, we look at the sign in option. So on the left-hand side is our PID reader. Okay, the PID reader has the LED showing the status. And on the right-hand side is just the LED push button, okay, which we're gonna use for sign in, sign out. So first step, okay, it show ready, and the operator 274 come in, right? He insert the transponder, okay. The transponder is inserted, and the LED of the PID reader turn green. Now, the operator want to sign in, so he pressed on the push button, right? And of course, the PID reader will check whether he has the right access. Can he sign in to the system? If he can, okay, so the system, his ID is signed in to the sign-in list, then the push button LED will lit, okay, showing that the key inside the PID reader now is signed in. Okay. Then you can remove your PID transponder, and of course the status of sign in on the LED push button will be removed as well. It will be unlit. Okay. Now this is the step for sign in to the machine. What about sign out, right? So sign out, same thing. You have PID reader and the LED push button. Now you insert the PID key or our transponder, and then the only difference is now after you inserted the PID key, the LED push button will lit because this key right here has been signed into the system, right? The sign-in list still have his ID. Okay, so it lit up. Then the operator pressed the push button, okay, to sign out. His ID will be removed from the sign-in list. The LED of the push button will be unlit, okay, and then the operator just removed his transponder, and that's it. He signed out. Okay, Now, what if you don't have HMI and you want to check whether this person has been signed in or signed out, right? So in this sign-in list, there's two ID, 274, 816, right? So if the same person, 274, walks in with his transponder inserted in, the push button will lit. Okay, that's because if you remember my previous slides, because this person already signed in, so this LED will lit. Okay, after you insert the key, of course. Now, what about another person? Another person, 563, is not in the list. Okay, then when he insert his transponder, the LED push button will not be lit, right? So because he's not signed in. So that's how you can check as well whether or not you have signed in or you are already signed out. Okay, that's basically the step how the key in pocket works. Okay, for the sign in, sign out, and the check in. Okay, now we will look into some functionality. Okay, as mentioned earlier, the key in pocket solution highly recommend to be used with our safety controller, either the small controller or our safety PLC. Why is that? Because with our certified system, we also have certified function block, okay, that can be easily integrated and used with our PID reader, for example, with our system. Okay, so in our software, PNOS Multi-Configurator, you can use this function block here, certified function block, and use for safety application. You can drag and drop very easy, and you can set all those parameters for the LED push, for the push button, for the PID reader, right? What kind of permission you need, and what the minimum permission, and so on. Now, please take note on two things, on one thing. For our safety small controller, the PNOS MB1 can connect up to 4 PID reader, while our PSS 4000, our safety PLC, can connect up to 10 PID reader. So depending on your design, you have to select the right safety controller to be used for your machine. Okay, we do have some customer that has very large system and use PSS 4000, but most of our customer they use the just safety small controller due to the cost and the requirement as well. And basically, sometimes you don't need to have the PID reader everywhere, right? You can set it up here at the main access point, and then you can request the access here first to sign in first, and then you can access different doors from there if your machine is not big. Right? Okay, so basically, yeah, we have the safety function block, particularly for this application. There's also a few other function block, safety function block they can use. So one of them is the blind spot check. This is the features that we need because there are certain machines where there's a blind spot and the person who reset the system may not see the person still inside the hidden area, for example. So this function block can allow you to set up another acknowledgement. Basically, when you enter the machine, right, you sign in, enter the machine, then you want to sign out. But if you use this function block, then you are required to walk into the area where is the blind spot, and there should be some kind of acknowledgement push button there. Okay, then when you already inspect the area and then you press the acknowledgement button, you have to return and sign out within the period of time. Okay, so this is actually one of the requirements if your machine decide to have such a blind spot. Okay, now last function block that I would like to mention, okay, is the delete save sign in list. Okay, this delete save sign list. So let's say a person operator, your operator sign into the system, right? Forgot to sign out, went home, or he lost the transponder. Then if you think back of the mechanical lock out take out, right? What would happen if the person bring the key home or lost the key? Usually you have a very long procedure to follow. You have to manually cut the lock itself, right? And then you can restart the machine. Of course, this is the ways you happen, right? So you have to replace the lock again and so on. Now we consider that might be a chance of this to happen. So we have the function block to allow the person to delete the sign-in list. So whoever have signed in, it can be deleted. However, there's a certain requirement for this. So you have to have a certain minimum permission. So you have to be, let's say, supervisor only, right? Or a certain thing. Of course, this can be set according to your preference, but you have this option that allows the supervisor, okay, already noticed nobody inside, right? The person is notified that he already went home. Then you can reset this, you can delete the list and then you can restart the machine to reduce the downtime. Okay, so that's the last function block for this application in Pocket. Now, our application can be used in various different industry, okay, automotive, logistic, packaging, but the most common one that we see is in the robot cell with the robot. Okay, so actually a lot of this we already mentioned. So there's a few advantage, more than a few. Yeah. So with this system in Pocket Solution, you have the information who is signed in, who is signed out, when did he sign in, when did he sign out. For example, does that person have the right access to gain the access to the PLC or to inside the machine? You can set that, right? Then we talk about the price. Of course, I'm not sure if anybody have used the mechanical trap key. They are quite pricey. So we have this system, digital system that can support on that pricing part. Okay. And we not even talk about the replacement of mechanical part, right? So it's a unique key, and then there's a lot of issues with it. Uh, Obviously, there was no such solution like this in the past. Then, of course, you have the blind spot detection that I mentioned earlier, and this is actually one of the requirements from the standard ENISO 13849-1. Okay, so another application that we have seen. Okay, so let's say you have the large area, your plants, right? Very large, 100 meters from end to end, 70 meters, let's say. A lot of time, if you use the traditional system, mechanical trap key, for example, you access in this area, right? You bring your key in, right? And when you do all the inspection, all your tests that you needed, then you have to come back right here. So that's one of the disadvantages, I guess, when you have to enter and enter and exit within the same area. With our system, we can put the few pit reader. Let's say we have 4 doors, we put all of them, right? If you started enter sign in from here, you don't have to come back right here. You can finish your task and then sign out at the other end, and then you can restart the machine. So that saves a lot of times, right? It's very advantageous. And once again, you have up to 20 people can access the cells at the same time, right? You can also remotely set to block your access because everything is the digitalized, right? And then if you lost the key, right? If the key is broken, if someone bring the key home, forgot to bring it back, there's a way that you can quickly prepare a new transporter for the operator, for example. Okay, so this is one of those. This is the example application that we have, and of course, we have some video example for this. Okay, let's have a look at some example here. Let me see if I can click back. Okay, let's have a look. Okay, so assume this is your machine, right? The person walks in, bring in, sorry, I'm not sure. Okay, bring in his transporter, plug it in, right? And let me go back quickly. And if you notice, oh, sorry. Okay, okay, let me just run this. Okay, because there's something that I would like to point it out. Okay, plug in, and you can see here on the HMI, right? He is appear his identification number, right? And then his access level. So with his transponder, he only have access to read the information on the HMI because it is set up that way for him. Now another person come in, right? And then he used his own transponder. His, of course, the ID is different, and then he has the different access. If you notice, now he can edit some kind of parameter here on the HMI directly because he is granted with his qualification and skill and his test. Then he is allowed to edit the parameter that related to the machine. Okay. Now, then this application, as mentioned, you can use with the interlocking device, right? Guard locking device, right? You can use with our pit gate box. This is the all-in-one. There's a pit reader there. There's a push button there and an emergency stop there. Okay, you can install this in front of your entrance. Okay, and of course you have to use our well, for this one basically is is our safety small controller PNOS Smart D2. Okay, let me run this quickly. Okay, once again, read only for this person. And another person have more accessibility, have more permission to edit the information. Okay. And these are the components that you can apply or use for your key in pocket solution. Now the person come in, want to access the machine, right? Put in his transponder. Okay, the information passed to the controller, send it back. Okay, you are authorized. Then you can stop the machine, right? And request the guard to unlock. And this unlocking will be done by the safety controller. Okay. Now the door is unlocked. He can go in to perform his task. Once he finished, okay, he put back his transponder again. Okay, request to lock, right? And then he can sign out. Okay. So this is the basic key in pocket solution that we apply to the different machines. Okay. And of course, there's various advantage of this. Of course, for example, up to PLD performance level, right? You can use with our PNOS multi. It has to be MB1 for your information, and PSS 4000 safety PLC, or you can use the third-party controller as well. However, they do not come with the certified function box for this device, for this application. So it might be possible, but maybe very complex. So this is recommended. Okay, and of course you have plenty of customization. You can provide permission to different person depending on their qualification and skill. Okay, and basically that is the video of the key in pocket solution example.